Hey, good evening. Welcome to
FunMath number 39.
Which is really
FunMath 40.
FunMath 40, but yesterday we accidentally did FunMath 40 before we did FunMath 39, so blah. But today we were learning about factorials. And can you tell me what 6 factorial means?
It means 6 times 5 times 4 times 3 times 2 times 1.
That's right. So when we talk about factorial for an integer, we just take the integer and then we multiply all the numbers down to 1. So 6 factorial is 6 times 5 times chicken?
4.
6 times 5 times 4, not 6 times 5 times chicken, times 3 times 2 times 1. Do you remember what 6 factorial is?
720.
720. Good job. Okay, so here's a fun problem for you. How many zeros are at the end of 100 factorial? I'm going to use our noggin for this. How many zeros are at the end
You mean all of them are just at the end of them?
of 100 factorial? No, just at the end.
100 factorial
Equals 199 times 98 times down to.
Times 3 times 2 times 1.
Right, and this number is going to be way too big for us to figure out, so we have to do something else. Now, do you know how you get a 0 at the end of a number?
It's a 2 times a 5.
That's a 2 times a 5. So we want to figure out how many 2's there are. When we do the prime factorization, we want to figure out how many 5's there are, just so we see how many 2 times 5's we get. Now, but we don't have to do both. Do you think there will be more 2's or more 5's in 100 factorial?
Probably more 2's.
More 2's, because every other number is going to contribute a 2, right?
Yeah.
But only every fifth number is going to contribute a 5. So all we have to do is figure out how many 5's there are when we factor 100 factorial. So how many numbers are going to be divisible by 5?
Well, there's going to be 100, 95, 90, 85, 80, and so on.
Yep. So how many is that?
It's a fifth of the total numbers.
That's true.
And there's 100 total numbers, so a fifth of 100 is 20.
20. Okay. There's 20 numbers divisible by 5. Does that mean we have 25's or do we have more?
Except there's ones divisible by 25.
There's one divisible. See, here we're counting the ones like 25, 50, 75, and 100 that also have 25's in them.
Those contribute another 2. 5.
Okay, so the ones that are divisible by 25 have one extra 5 in them. So
there's
how many?
4 of those.
What are those for? Go ahead, write 4.
25, 50, 75, and 100.
Okay. So there we go. So we get 25's just from the numbers that are divisible by 5, and then we get 4 extra 5's for the ones that are divisible by 25. So the prime factorization of 100 has how many 5's in it? 5 to the
24th.
5 to the 24th. And it's going to be 2 to the something, we don't know what, but it's going to be more than 24, right? How do you know that right away?
Because at least every other number.
There's 50 numbers that have 2's in them, so it's going to be at least 2 to the 50th, but then you have to count the ones that have 4's that are divisible by 4 and by 8, 16, 32, and 64. So there's going to be lots of 2's, but there's going to be 24 5's. So we're going to have a 2 to the 24th times a 5 to the 24th, which means 24 zeros.
Yowza.
At the end.
That's a big number.
Yeah, 100 factorial is a big number. Off the top of my head, I do not know what 100 factorial is.
Probably the calculator would know.
Probably not. It's probably too big for the calculator, but Mathematica would know. We can check after we turn off the video if you want. You want to check?
Yeah.
Alright. Good job today. 100 factorial has 24 zeros at the end. And the way we solved that problem was we said that to get a 0 at the end, you're going to need a 10, which means a 2 and a 5. So we have to figure out how many 2's there are and how many 5's there are. But then we said, oh, wait a minute, there will be fewer 5's.
Yeah.
So let's just figure out how many 5's there are. Because it doesn't matter if there's 1,000 2's, there's only 24 5's, so you can only get 24 zeros.
Yeah.
Okay? there we go, 24 zeros at the end. FF. That's a neat factorial problem.